I'm going to create a copy of this file so that I don't mess up the original, and I will work on the copy. I will complete each task on all devices first before moving on to the next task. I'm going to use the fast forward button right away to get the links up, and we can get going. All right, the first task is configure host names according to the diagram and the banner on switch 1 with your name. So switch 1, enable configure terminal, and then host name, I'm going to call them S1, 2, and 3. And then to configure the banner, I'm going to use the command banner message of the day special character cyber quince, and then that same special character at the end. Switch 2, enable configure terminal, host name S2, on to switch 3, enable configure terminal, host name S3. Next task is to configure access interfaces and VLANs. So on switch 1, we will join Fast Ethernet 0/1 to VLAN 5 and Fast Ethernet 0/2 to VLAN 7. But prior to that, we need to change their default mode from dynamic auto to access. I will explain this in a bit more detail when we get to trunk interfaces, but for now, just bear with me. Let's get into interface Fast Ethernet, and I'm going to start using the tab key now. 0/1, switch port, mode access, switch port, access VLAN 5. I'm getting this message because VLAN 5 does not exist on the switch. In order to avoid getting this message, although it doesn't mean anything is wrong, this is perfectly legitimate, I will create VLAN 7 prior to configuring it on Fast Ethernet 0/2. And the way to do that is simply type in VLAN 7, and then we are thrown into this VLAN configuration mode. I'm going to exit out of there, and I'm going to get into interface Fast Ethernet 0/2, switch port mode access, switch port access VLAN 7. Moving on to switch 2, interface Fast Ethernet 0/1, switch port mode access, switch port access VLAN 5. And now I'm going to start using the short forms of commands instead of using the tab key. You can continue to use the tab key or type the entire command. It's your choice. So I'm going to just type in interface F 0/1, switch port mode access, switch port access VLAN 5, or that's actually VLAN 7. So Fast Ethernet 0/1 is connected to a PC that should belong to VLAN 7, and interface F 0/2 should belong, so switch port mode access, switch port access VLAN 5. Now, you don't actually even need to configure these access interfaces as static access. That's because these switches, so all of the interfaces on these switches are by default set to dynamic auto mode. In this mode, if on the other side of that interface, so if that device that you connect to that interface doesn't actively try to change that link into a trunk link, it's always going to be an access link. You can see that in this PDF file that I've provided. So there are several modes. There's dynamic auto, there's dynamic desirable, there's static trunk, so to say, and then there's switch port no negotiate. We can talk about this one, I believe, later when we talk about DTP and VTP, but for now, just ignore this one. The interesting mode is this dynamic desirable. That is the mode that makes the interface actively attempt to convert the link to a trunk link. So what does this mean? If we look at this link, for example, if on one side we don't change the configuration, it's going to stay dynamic auto. In order to see those modes, we will go to Show Interfaces Switch Port, and we will be able to see all of these modes for all of the interfaces on switch 1. Fast Ethernet 0/1, we have manually configured it to be access, so it calls it static access. And then if we go to Gigabit Ethernet 0/1, we want that to be trunk, but right now it's dynamic auto. Its operational mode is static access. So administrative mode is either by default dynamic auto or statically configured access or trunk. And then operational mode is going to be the mode of the link that depends on the other side as well. So depending on what is configured here on the neighboring interface, you're going to get either access or trunk. So let's configure Gigabit Ethernet 0/1 to trunk, and then let's see what happens. I'm going to go to Configure Terminal, Interface G0/1, and I'm going to say Switch Port Mode Trunk. I'm going to go to Fast Forward, and then I'm going to issue that show command again. Only to do that from the config mode, I need to use do show interfaces switch port. When you use the do command, you won't be able to use the tab key. Just keep that in mind. Okay, let's go to Gigabit Ethernet. Here it is. Administrative mode, trunk. Operational mode, trunk. Now let's look at, by the way, if you haven't figured it out so far, you can get out of these printouts by pressing either the Q key on your keyboard or the escape key. So on Gigabit Ethernet 0/1, we have administrative mode trunk, operational mode trunk. If we go to switch 2 and issue the same command, do show interfaces switch port, whoops, and then go to Gigabit Ethernet 0/1. Administrative mode is still dynamic auto because we haven't changed that ourselves. So that's the default mode. But operational mode is trunk because, as we could see in this PDF, if you have dynamic auto on one side and trunk on the other side, the operational mode of that link will be trunk. Let's configure switch 2. So on switch 2, we have 2 Gigabit Ethernet interfaces that should go to trunk. So I'm going to use the range command. The range command is used to configure several interfaces at the same time, and they can only be consecutive interfaces. So I'm going to say interface range Gigabit Ethernet 0/1 to 2. And I'm going to say switch port mode trunk. Then let's go to switch 3 and say interface Gigabit Ethernet 0/2 switch port mode trunk. Let's use fast forward to get the interfaces up. And that's it for the third task. Fourth task is to configure IP addresses on PCs. To do that in Packet Tracer, open the PC, go to Desktop tab. There is another way to do this, but I like this way better. Go to IP configuration and type in the address. Now, since we don't have any routers, any gateways or servers in this network, I will just start from 1. So it's going to be 192.168.1.1, and I'm going to copy this first part because it will be the same for all PCs. Subnet mask is the default class C mask, so I'm just going to leave that like that. PC2 is going to be .2, PC3.3, Now that that's done, we can try ping. Let's ping PC1 to PC3. That's successful. Then we can go from PC1 to PC5. That's a bit further away, and that's successful as well. But now if we try to ping PC4 from PC2, that is going to fail. To send the ping again, the easiest way is to just double click on this evil eye or egg or whatever the hell it is. In order to see why that ping is failing, we will use the simulation mode. To enter the simulation mode, click here. And I'm going to go forward. And we will see this packet going from PC2 to switch 1, and then to switch 2, and then that's where it gets discarded. To see the details, I'm going to click on the packet, and in order to see what's the exact problem here, I'm going to go to the last layer possible and just read why it got ditched. So the reason is switch does not have the VLAN indicated on the IEEE 802.1q frame tag. It drops the frame. As I've mentioned in the presentation, in order for a switch to be able to process a packet, it has to already know the VLAN that packet came from. So that VLAN needs to exist on that switch before the packet gets to the switch. Here's the deal. When we configured those access interfaces, each time we would join an interface to a VLAN, that VLAN would automatically get created on that switch. Now, switch 1 and switch 3 have both VLANs on them. They have both VLAN 5 and VLAN 7, but switch 2 only has VLAN 5. So if we try to send a VLAN 7 packet through that switch, it's not going to recognize that VLAN because it's not configured on the switch. The solution is actually quite simple. I'm going to go back to real time, open switch 2, and just say VLAN 7. Now let's try the ping again. Okay, I'm going to say fast forward. And now it's successful. Now let's look at the simulation. This time we don't see the ARP packet because the ARP tables already got updated on the switches. So now I can only see the ICMP. And I will actually use this example to explain into more detail the whole VLAN story. So when a packet is generated for the first time on the PC doesn't really know that it belongs to a VLAN. It will create a regular ICMP packet and send it off down the link. The switch will receive the packet and look at the interface where it came from. That interface belongs to VLAN 7. So the switch will add a tag onto that packet, and the tag will say VLAN 7. So this packet belongs to VLAN 7, and it can only be sent to other VLAN 7 or trunk interfaces. The switch then looks at its interfaces, and it will see that there is one interface that belongs to a different VLAN, so that packet can't go there. And then there is this trunk interface, which can carry any VLAN. The switch will send that packet down the trunk link. The same logic applies on switch 2. There is this VLAN 5 interface and the trunk interface, so it's obvious that this packet should go to the trunk interface. And then on switch 3, there are two interfaces, a VLAN 5 interface and a VLAN 7 interface. Obviously, this packet can only go to a VLAN 7 interface. Now, what happens to the tag? Once a packet is, first of all, received on an access interface, it is tagged. But once the receiving switch, so the last switch on the path, receives that packet and it processes it, it sees that it belongs to VLAN 7. Once the switch decides where to send the packet, if it is sending it to an access interface, it will remove the tag. So packets are only tagged while they are traveling a trunk interface or while they're being processed by a switch. The PCs don't receive tagged packets. This can happen due to misconfigurations. For example, if you configured this interface as trunk, the switch would not remove the tag, but the PC would not be able to read that packet. And the reason is because to tag packets, these switches use a .1q protocol, and the PC doesn't really know what that is. So it won't be able to read the packet, it will simply discard it. You can even look at the headers, although the packet tracer doesn't really show the .1q tag, but you can see here that we have a regular Ethernet to header in the packet. Because we are at the PC right now, there is no tag on that packet. And then if we move forward and the PC starts to send back the packet, when we look at the packet at the switch, inbound PDU details, so this is the packet that was received on this interface, still only Ethernet 2 header, and then on the outbound interface, it will have the Ethernet 802.1q header. You have your answer at the end of this document, and of course the command we used to resolve this issue. That would be it for this lesson. See you in the next one.